Good morning, afternoon, evening, whatever it happens to be in your part of the world. We'll roll through the Maestro and some of the features you can use to hopefully make your life a little easier at the hatchery. So, basic questions that we're hoping to answer is what should a SCADA system do for you? How does the Maestro accomplish this? And how to use the information to get better chicks. That's where Chad comes in. SCADA system should basically make the life at the hatchery easier, giving you tools in one place to do common tasks in your hatchery and to view the status of your equipment all from one spot. So some of these hatcheries are pretty large, and it would be horrible if you had to run around to every machine to see what was going on. And the SCADA system is intended to kind of bring that all into one place for you in one package, all on the computer, for you to get a great overview of your facility and all of the happenings throughout. We do this pretty simply with the hatchery overview, as you can see here. The hatchery overview screen allows the user the ability to see if there are any machines alarming. As you can see, I've got a couple machines down here in this bottom right area of the screen indicating alarms. Temperature and humidity alarms are shown. Any alarm at all will cause the machines to show up in red, and a zonal alarm will be indicated by what zone of the machine is highlighted, whereas a global alarm, something like a fan failure, for example, can be a global alarm. It be indicated as in a whole machine turning red. You can see also that the color yellow is used to indicate a machine that's out of service. This means the machine has been taken out of service locally at the machine, and Maestro is just indicating it. That's at the top right corner up here. You can also see when a machine loses communications. The blue indication is an indication of a problem you have, unless you're physically knowingly doing something to remove communications, then we would definitely see that as a problem and an issue we would want to get notified. Gray machine, like you see here, is an indication of a machine that's been taken offline. Uh, you take machines offline when you're performing tasks on machine, and for example, if you want to take the power completely away from a machine for some reason, so it would lose communications. But if you take the system offline, Maestro isn't continually polling, and it will also not cause an alarm for a comm failure when it's in the offline state. I don't have a sample of an orange machine here, but if an alarm is silenced or delayed at the machine, then you get a machine turns orange to indicate it. Also, the global alarm indicator, you can see kind of the globe with the horn in it. It goes red when there's an alarm and green when there's no alarm, and that can be seen in every screen of the Maestro system. So navigation, we use these buttons at the top to navigate through the different screens within the Maestro. Your version is indicated in the top left corner up here. If we're online with you, we may ask what version are you running, and we may recommend you go get the latest version off of the website. I always recommend you run the very latest version. We usually only add. We can't think of any time we've had to take away. We've got buttons for like the hatchery map. You can also view a power monitor over here. It's not a very effective power monitoring solution. It's strictly monitoring the heating and cooling and fans on the machine, and doing an add of an estimated power usage to to determine power usage. Disk activity, well, it's kind of self-explanatory. If you do a export of data or something, there will be disk activity. Graph, this button is very important when you're wanting to review graphs of machines. Alarm log, a very important tool for managing your hatchery, and certainly the calendar is one I think you people will make use of. The remote alarm screen, this button brings up the remote alarm screen, and that is a screen that can be placed in another area of the hatchery. We'll get into that a little bit later. These buttons are for set point programming, stage programming, and stage program control, or start and stop of stage program, or changing steps. The legend, alarm acknowledgement, ledger view, and engineering configuration are the following buttons as well. Alarm monitoring, we talked about a little bit. There's a button that takes you to the alarm screen, but also when you double click into a room, you'll get what's known as room view, and the room view will give you enhanced information. So not only do you see the actual temperatures and humidities, but you see the set points next to them in a lighter, smaller font. Other than that, it'll also indicate fumigation activity if you're using our system to fumigate. You can see it up here in this next to the alarm. The global alarm is also a global fumigation indication. Alarm conditions are called out much like they are on the overview screen, and out of service status as well. Alarm monitoring, this is one of the most valuable tools as you run your hatchery. The ability to filter on particular types of alarms or a particular machine that's been giving you problems is all built in this system. Up here you can filter on selected machines, so you can select a machine, come into this view, and you'll only see alarms. You can also filter on only active alarms. If you look at our list closely, you'll notice we have both red and green. Red indicating an active, there's no end time. Green indicates an alarm that has happened and cured, or passed, I should say. The green alarms may not be as of much interest to you at a given time, but it's always nice to have the history and see what's going on. You can also filter on the specific alarm type. Maybe you've got a lot of over temps happening and you want to see what over temps have occurred, or high temps, fan failures, whatever it might be. You can select the type and filter on only that type of an alarm. The other information down here, as well as the start time and the end time, you'll note an acknowledge by and a notification. The alarm log indicates if there was a email or text message sent out to notify. Acknowledgement means that somebody in the hatchery has acknowledged the alarms at that time, and that therefore if you're getting a notification, it'll have the name of the person on the notification who acknowledged the alarm. The alarm log is a circular log that will hold up to 2,000 alarms. Its content can be exported into a CSV file. You can set that up to happen daily, weekly, whatever you feel is necessary. We talked about the remote screen, and this is usually the screen we recommend you show on the remote screen. As you can see, the idea here is that we show machines that are alarming or not alarming in green, alarming in red, and we list the last 6 alarms that have occurred. So you're a night guy who maybe for some reason you don't want to give them access to the office that the Maestro computer is in. This screen can be up to 50 feet away, and you show this data on it, and he can look at it and say, oh, I need to go to this hallway and this machine and look at what's going on. I guess if you're at this particular hatchery, you're going to be pretty busy running around. You got a lot of alarms going on. The OR alarm aspect of the Maestro is a dial out system. So the OR alarm comes actually with a secondary monitor and the 50-foot green cable to mount that monitor, and it also allows for dial out using telephone. So while I mentioned earlier the Maestro can text message and email alarm information, the OR alarm is what we like to think of as a safety net. For example, relying on email and text messaging is fairly reliable, but telephone call to backup alarm makes a lot of sense. And you can configure on these screens how you'll be notified. You can configure them to just sound the horn of the OR alarm, show the light, activate the dialer. So, in your most critical alarm situations, you probably want to activate the dialer. And the selected contacts means it will email or text message for these alarms if you check selected contact. The system also has the ability to disable notification by selecting the day of the week you would like to disable it, and from what time to what time. And again, remember, you'll be selecting the times that you do not want it to send out notifications or dial out messages. There's also an alarm delay built into this system, and the idea with the alarm delay is, well, one, give it some delay so you don't get every little nuisance alarm that triggers, but also don't give it a huge delay, maybe somewhere between 1 to 3 minutes, I would say. And then when you're configuring users, you can create what's tiered notifications. So maybe I let my maintenance man get the first notification by selecting time 0, which means there will be no delay. He gets notified right away. Maybe I let the backup maintenance guy get the second one by giving him a times 1, and then if I want to be notified later, I might be a times 2 or times 3, giving them a chance, hopefully, to indicate that they are working on the alarm by acknowledging it with the acknowledgement button. Again, if they do acknowledge that, then the remainder of the notifications that go out will let you know they've been acknowledged by somebody. So somebody is working on it. And down here is you can set up the contacts with the delays like we discussed. And as you can see, we let you put in either email or text message phone numbers. The Maestro system is also very handy for helping you to send set points, stage programs, start and stop stage programs, jump steps. You can do this to groups of machines at a time. A Maestro system can store set points for you, so you can save a machine's particular set points or stage program to the computer, and then you can pull that data back up when you need to. I know with stage programs, this is pretty typical that you'll see people storing different stage programs to deal with old flocks, young flocks. So that's more of a hatchery specialist side of things, but it's nothing unusual to see several stage programs stored on one Maestro PC and them selecting the correct one. The same can be done with set points as well. I'm gonna pop right back in there and also talk about the group sending of the set points in the stage program. If I wanted to, I could send a stage program to as many machines in a given room. They have to be of the same type. In other words, I can't select setters and hatchers. The system uses different stage programs so that you don't accidentally ever send a setter stage program to a hatcher and vice versa. And I can't go selecting machines in multiple rooms. If I want to send 2 rooms, I got to send 2 group sends to get all the rooms done. But as many machines in a given room can be selected, and then they just show up on the list, so you can even review before you hit send what machines you're actually sending them to make sure the list looks right to you. In our rock machine, the latest control we offer, we actually give you the capability of also not only saving stage programs and set points, but also machine configuration. So things like your PID settings can be stored. You can store one for every machine, or what I find most people do is they have one that they run in all of their setters and hatchers. Whatever system works best for you, we give you the ability to store an unlimited number of these just by giving them specific names. It's all going directly to the hard drive on the computer. This is very handy in the case of hardware failure or fault. You can quickly replace the hardware and load. Imagine loading the configuration back in with the click of a button, and also being able to get the right stage program and even to the right stage, all with a click of the button from the computer. The calendar tool that you see here, very powerful for especially for maintenance tasks, reoccurring maintenance tasks. Can be machine maintenance, it could be room maintenance, any maintenance task. We also provide you with like miscellaneous tasks if you want. That's the picture of the box is intended to be the miscellaneous task. We also have set, transfer, and hatch tasks. So again, just like alarms, it's possible to get text message and email notifications of these tasks sent to the people that they need to go to. Again, if we go back up to our contacts list real quick, you can see down here on the contacts the maintenance symbol, the set, transfer, and hatch symbol, and the miscellaneous. So if you've got a contact that's, for example, your maintenance guy, you would probably check the maintenance symbol. But somebody who transfers birds, you might be looking at the set and transfer or hatch symbols for them. We've tried to give you just about every way we could think of as far as reoccurrences, so you can set it for a single occurrence. You can set a task to happen, repeat every 2 weeks, maybe every 2 days, every 3 weeks, every 4 weeks. And you can also say repeat on every second Tuesday of each month. Very useful tool for managing the hatchery. All of your information on the manuals and so forth can be downloaded at this, and I do believe this is the key for Chad Daniels to take over.
Good morning, everyone. I hope we've learned some things from Paul. It's always good to go back through the toolbar and all of the functionality of Maestro. I've worked a lot with Paul over the years, and the things that have been added to the Maestro system have definitely made it a wonderful tool in a hatchery. And I oftentimes find myself in a hatchery that is way underutilizing all of the capabilities of Maestro. So I think this is a webinar. It's a good reminder of everyone to challenge themselves on what some of those extra uses are of the system and how to get a little bit more out of it. So anyway, to start with, for my portion of the presentation, we're going to dig into a few of the graphs. And so it's always kind of good to start with a statement. And we say that you can tell a lot about a man by looking at his shoes, and we We say that about a chick by looking at their graphs. And so when we look at some of the type of information today and the graphs that are available in the system, we focus a lot around the various types of incubation equipment, whether it's single stage or multi-stage, and the various types of hatcher machines that we have in use today. And you know, for locations that don't utilize control systems on incubation equipment that allow you to utilize Maestro, it's just a reminder to put effort into the types of upgrades that allow you to utilize this. But it's pretty easy to dig into some information around warm-up time on single stage, also looking at setters the last 7 days of incubation, and also focus a lot on hatcher machines as well, because it affects chick quality so much. So we're gonna dig into a little bit deeper with this, but this slide here is kind of a reminder to as a good tool for you to use in your hatchery, is to develop a known good catalog of graphs showing ideal conditions that give solid, you know, reproducible results. And what we mean by that is to develop that. When we know with single stage incubation, oftentimes we have a stage where we hold eggs at a lower temperature, and then we have a warm-up stage. And when you have a machine that warms up consistently and it's on time and it does things correctly, like in this first graph here on the bottom left, it's good to have a catalog of those types of graphs to represent what you're shooting for with every machine's performance. To begin with, we'll talk about this particular graph in general, starting with this warm-up stage. First, we look at the amount of time it takes for the machine to come up to temperature. And so from a troubleshooting perspective, we have an ideal time period we're looking for. And so if it's a little bit longer than expected in specific zones, so in this case, we have one zone here that took an extended period of time to get up to temperature, and you see that highlighted now. Oftentimes we find this as what's referenced as a zonal issue, and oftentimes we can find faulty heating elements in that specific zone, or say a faulty solenoid valve. So in other words, the machine is trying to heat up using an electric heat only, but we may find a chilled water solenoid that is not shutting off completely. And so we may have leaky, a little bit of chilled water migrating into the cooling coil, causing an extended period for warm up. And then oftentimes you'll see air leaks specific to that zone where the damper may be out of calibration, or the damper itself for that particular zone may have you know, dislodged or become disconnected from the main damper actuator, and therefore is bleeding air into that specific zone. So it's relatively common when troubleshooting startup or this warm-up stage to see a zonal effect. And this can be a little bit easier to troubleshoot, but there are several things to look for. When we look at a machine that, in instance, what we call more or less a machine level fault, it's something that causes the whole machine to warm up a little bit later. So this would represent a graph of a machine that had a very extended warm up period. So oftentimes we find a machine like this where all of the dampers are open on the machine. In other words, we're allowing fresh, cool air from the room to migrate into the machine at a heavy rate, causing this extended warm-up period. If you have a single stage incubator that uses hot water as warm-up, you may find faults in that hot water system, or you may have a blocked strainer with that hot water system that's not allowing adequate hot water flow through the machine in order to help warm up the machine. And this is what we refer to as a machine level fault, not a zonal fault, but a machine level fault. But it's always a great idea to always look at your machines every time they do a warm up and get a good known graph of what it's supposed to be. And when you find a machine that took this extended period of time, this machine was probably as much as you know, 12 hours behind, then it creates a situation where you probably better document what machine this is, what day it was set, what day these chicks are expected to transfer and to hatch, and to document that these chicks are probably going to come off a little bit late if you don't make some kind of a stage program adjustment to try to make up for that. So that's the critical piece of trying to monitor these warm-up times, because it's no good to come in on a Monday morning at 6 a.m. expecting to open the doors on the hatchers and pull chicks, and there's a bunch of wet chicks looking at you. So you'll know this 21 days in advance if you'll check your machines after warm-up. So when we take it a step farther, once we get past warm-up, something that's a great idea to do is look at consistency from zone to zone when we look at the amount of heating or cooling duty between the zones. So oftentimes you see here where it's highlighted in the top portion of this graph where that bottom or zone 4 had extended period of heating. I think in this case that's the red line, so that's actually zone 1 that had an extended amount. And oftentimes this can come from a bad calibration or a faulty heating element, or again could be faulty solenoids where you have a chilled water solenoid that is leaking. So it's important to monitor machines once they've come up to temp, and once they're all the egg mass is at operating temperature, the machine should settle down and all the zones should be fairly consistent. Another thing that we'll do is things that can cause inconsistency in machines are not having good closed sealed dampers, or not having dampers that function completely controlling the volume of air going through the machine. And we'll monitor or look for issues with that based on looking at the humidity level. So in this case, we see that we have a fairly normal humidity curve where it's following the set point and the damper is controlling this. But if I have a machine that is having an issue, I may see that here I was probably leaking a little bit of air through the machine, not allowing the humidity to get anywhere close to the set point. And this is at a time period where you have a relatively low damper opening. So a lot of things can cause this issue, but this is an indicator that you've either got too much air going through the machine or you've got an issue with the damper. So it's always important to monitor the humidity in a single stage setter as well to help troubleshoot through some machine problems. In addition, with the humidity, we can, once we get a little bit later in the incubation stage, again, we look for a time period where the eggs become exothermic. So in other words, the embryo now is large enough physically and it is producing enough heat that a machine will transition from periodically bumping the heat to actually start functioning or utilizing the cooling. Again, it's a time period where you want to focus in on. When we look at that during that time period, there's a lot of things that can cause a machine to be consistent with controlling those temperatures and how well the machine manages temperature. And it can be things such as your loop gain or cycle time or offsets when it comes to a Gen 4 in a rock machine. It can be PID settings with heating or cooling, and how well the zonal valves work in order to help control temperature. So there's a lot of little details during that transition time between the really about a 10, 11, 12 day of incubation where that exothermic period begins. And so that's just another strong time period to really monitor about what's going on in your machine. When we look at the next slide, we're looking at a damper, and we're trying to determine at what day during incubation did it reach 100%. And so this can often indicate poor room conditions. So if we have a room that is very cool or very dry or low in humidity, or we have a very low pressure setting in our plenum, in other words, we have a high differential pressure, then the machine will have an excessive volume of airflow going through it. And when you see this, oftentimes you'll have a machine that just has a difficult time at maintaining humidity, but the damper itself will follow more of a pattern that's like this, where we're low in our humidity and we're not achieving set point, so our damper will continue a path of just following the minimum damper opening in the stage program. So this is just an indicator that we probably have one of these situations influencing the machine. The same goes when we look at a machine that works in the opposite direction. So if we have a damper opening that is not, and this is our normal known good graph, when we see one that reaches 100% opening very early and our humidity is consistently above our set point, then oftentimes that's an indicator that we either have really high humidity conditions in the room or maybe a lack of differential pressure across the machine. We're just not getting adequate airflow through the machine. And you can see that in this part of the graph. So again, it's one of those pieces that you can focus on and look into. When we look at multi-stage, now that we've talked quite a bit about single stage, when we look at multi-stage, there are several opportunities to focus on. One being, in this particular case, we have a multi-stage setter that is out of balance. And I say that because it has a high percentage of heating in the front zone and a high cooling percent in the rear zone. So essentially the front's doing all the heating and the rear's doing all the cooling, so it's referred to as a machine that's out of balance. So always focus on a machine like this to look at check the opening of air inlets. Check the opening of air inlets, our fresh air distribution internally in the incubator. So in this particular case, where we're heating a lot in the front zone, we may recognize that as the fresh air enters the machine, the adjustable damper over fan number 1 may be wide open, and it's allowing too much cool fresh air from the room to just be dropped into that zone, and it's causing that zone to have to heat, and you see up here an extended period of time. Now, if we're dropping a lot of air into that zone, we're probably not going to get enough air into the rear zone, and so it's followed by a situation where we end up with a lot of cooling that has to occur in the rear because it's not getting enough cooling air. So this can be an indicator out of balance of that fresh air distribution. It can also indicate that maybe the temperature probes need to be calibrated, or oftentimes you have a door seal on the front of the machine that's letting a lot of cool air migrate into that front zone and causing that excessive heating in the front. And that may be causing overheating in the rear and causing it to have to cool. So there's a lot of little details around this that can be dug into with multi-stage. Here's another case of an out of balance machine. In this particular case, the setter has high cooling demand in the front zone and high heating demand in the rear. So it's almost the opposite of the last machine. Again, one thing to point out on this machine that's a little bit different is that it does not have split cooling. So in other words, essentially the cooling, when that functions, it's going to cool the rear of the machine first, but it'll cool the entire machine. So this could be a situation where we're not getting enough fresh air in the front zone, driving the cooling demand in the front, and that cooling demand in the front is overcooling the rear. So you'll see a machine that sits there and cools in the front, and then immediately followed by a heat pulse or a heat demand in the rear. And so again, that can be fairly common if you don't utilize split cooling, but it's still a machine that's out of balance. You always want to go back and check fresh air distribution, check water valves or solenoids, because oftentimes when you see excessive heating in the rear, it's driven by the fact that the solenoid for cooling water is not completely shutting off. There may be some debris that's keeping the solenoid from closing, and it's allowing a little bit of water to leak in, and that's forcing the rear of the machine to have to heat to make up the difference. And also, review temperature probe calibration again as well. So when we look at a setter with a high percentage of cooling in both zones, obviously it's a little bit more balanced because of the consistency in the cooling from zone to zone. But what this is also an indicator of is that we may have a room with a high temperature, or we may have a lack of fresh air or poor room ventilation, or the exhaust system is not functioning as it should. It's not allowing the machine to breathe properly. In addition, there could be issues with a cooling water system, such as not having enough cold water or low pressure on that water system. Also, with machines that have the filtering or a strainer on the chilled water, it's a possibility you may have a clogged strainer. And then a lot of times with older multi-stage machines, we'll commonly see cooling coils that are restricted. In other words, over an extended period of time, you have debris or rust particulates that settle into your chilled water system, and these will find themselves into the chilled water coil, and it's really hard to get that debris out of there without just opening the coils up and flushing water through there. But a restricted coil will also act like a plugged strainer, and you'll see that with machines that are running excessive volumes of chilled water just to try to maintain the temperature. Another good function of Maestro in looking at graphs is recovery time following egg set or transfer in a multi-stage machine. So when we see here in this particular graph, what we're looking at is when the egg set was made, look at things such as how long did it take a machine to recover. And again, it's good to have a known graph because you can compare that to multiple machines at egg set and understand, something to review a process or something that occurred during egg set that may have affected that. Also, we look at how low did the temperature get to, and commonly if we have an egg room that is running very cold, and so our eggs at set are really cold, we'll see that temperature drop excessively low, indicating that it's going to take it longer to warm up. And so that may be an indicator of checking some egg room temperatures. We also check for zonal heat consistency. And then how long was the machine leveled during set? Not activated on this particular screen, but you can activate your turning. And what's very common is you'll see hatcheries that during egg set, a machine may have been leveled an hour or 2 hours before the eggs were ever set in it. And then it may have been left leveled for several hours after egg set. And you'll see that during egg set and sometimes at transfer as well. So it's great to use the Maestro system in a multi-stage hatchery to monitor these egg set, transfer, even if you have a 1 day a week, or if it's a common procedure to clean the floor of the incubator, say following transfer. It's a good idea to see how much that disrupts your incubator and see if there's something about that process that could be potentially modified slightly in order to not affect the machine quite so much. So Maestro can be a great tool for both single stage and for multi-stage setters. When we look at hatcher machines, there's a couple of different things that we really try to focus on. Matter of fact, there's a good number of things on a hatcher machine. The first thing is generally I look for, after transfer, how long did the hatcher have to heat to regain the egg mass temperature. So when we see in this graph here where the egg set was made and the temperature came back up, here we saw heating that occurred for a long period afterwards. And what that tells us is that there's a possibility you may have faulty heating elements. It could also tell us that it indicates that the eggs are getting too cool during transfer. In other words, we pulled the setter buggies or the incubator trolleys or the farm racks out of a multi-stage, were removed out of the incubator well in advance of transfer, or maybe they stayed in a transfer room for too long before it was actually put back into a hatcher. So that's the beginning piece when it comes to a hatcher machine, is how long does it take to get back up to temperature once I've made my transfer. Following that, we usually then focus on the consistency of operation of the machine, but we'll also look for tracking our wet bulb. So during pipping, which is indicated the last few hours of incubation by the peak or large increase in wet bulb, you should review a temperature to make sure that you're not overcooling your chicks, usually indicated by what I refer to as basket migration. It's sometimes a good idea periodically during this peak here to open a hatcher up periodically and look and see chicks that are out, that are somewhat dry, but hopefully you see chicks that are spread out throughout the basket and not all on one end of a basket or another, indicating that they're trying to get warm, or maybe they're too cool. So it's a good idea to monitor that wet bulb for various reasons, but in this particular case, what we're looking for is a wet bulb that's not getting too high of a peak, which may be an indicator of. So in this is a known good graph. When I compare it to one like this, where we see really high wet bulb conditions that stay flat for a long period, and we're getting as high as a 96-degree wet bulb there, we may find things such as the auxiliary blower settings not correct, or we may find poor room conditions, faulty inlet damper, or lack of plenum pressure. In other words, for whatever reason, we're just not getting adequate airflow through the machine during that time period, and we're seeing really high wet bulb conditions that occur. So it's really, really good. I know I run into this a lot when I visit hatcheries, and I mean, I agree with the fact that a lot of times poor water quality in a hatchery indicates that we don't want to spray water in a hatcher machine if that water could essentially be a source for bacteria. But it doesn't mean that we don't want to put a water bottle and a wick in there so we can monitor this, because it's so critical to really know when your chicks are pipping and what level of humidity that you're achieving in the machine, because it helps manage things such as airflow and set times and transfer times and things of that nature. So I'm a huge advocate of making sure that you monitor this when it comes to a hatcher machine. In addition to that, leading up to pool, we try to review that curve, and we really want to see what time that the curve starts and what time the curve ends or starts back down. And this is telling me more so than anything what my hatch window looks like, because that's what this is. When people talk about hatch window, this is what I'm looking at. And so oftentimes this helps me when I look at it the day before pool. I see where my peak is, what time it started up. It's going to tell me whether my chicks are going to come out on time, or whether they're going to be maybe a little bit ahead or a little bit behind. If I've got a big hatchery and I have 20 hatcher machines to pool, monitoring this may help me determine where I start my pool at. Instead of just starting at one end of the hallway and going to the other, I may have some machines that are a little far ahead, and it may be a good idea to pull those first to avoid overheating or dehydration. So it may also indicate a change in set time or a change in profile in my incubator. So if I look at this as a known good, a lot of times if I have a machine that's not running well, such as an incubator, for instance, I may end up with a humidity curve that looks like this. So it peaked early, but it stayed too high for a long period of time, meaning I had a pretty big spread in my hatch window. I probably had some low temps at some point in my incubator, along with some higher temps. So the higher temps drove the early ones, but the low temp caused the ones to come off late. And you see that with a long window like this, that's up to a 48-hour period of time. So conclusions on the back half of this presentation is use Maestro to complement, strengthen good hatchery practices. Have your known good graphs that you can refer to. Become familiar with Maestro features. Don't be afraid to ask questions, or if you don't have your manual or a current manual on your Maestro, like Paul said, it's a good idea to make sure you download that and have that available to review. Develop your known good reference library, and then compare regularly alongside other operations. Don't wait until you have an issue. And that's, as a company, we have multiple hatchery specialists throughout the world. We're always here to receive a request to spend time looking at your Maestro. That's one of the things I do a good bit of time with. I utilize TeamViewer, have hatcheries call me up and say, hey, can we set a time for Thursday? Can you get online with my system? Having some issues around managing the hatcher temperatures, or maybe they're having some issues around, you know, the way their chick quality is coming off. And so we can use those online team viewer sessions to monitor your equipment, and we can do that with while we're on the phone or while we're doing a Zoom call, and can verbally communicate along with looking at the same graphs. So don't wait till you have an issue before you schedule time and put more effort into monitoring those things. Any questions? Well, I either did a really good job of covering all the details, or no one has any questions.
Perfect. Thank you very much for that, Chad. So again, absolute wealth of knowledge there. And if there's any specific questions anybody's got, feel free to reach out to myself, Chad, or anybody on the Chickmaster service team. If you don't have our details, you can always drop a note to support@chickmaster.com, and we'll get back to you as readily. The next webinar is going to be on chick grading, and that's going to be on Tuesday, the 1st of September at 10 a.m. Eastern Standard Time. And then again on the 8th of September in Spanish for our Latin customers and Western European customers as well. So again, thank you everybody for your time today. If you have any questions, feel free to reach out to us.